All right. Good day, everyone. Today I'm gonna be talking about variance and standard deviation. But in this aspect, it's going to be based on group data because this variance and standard deviation is part of statistics. Is a measure of dispersion. Okay, under the measure of dispersion, you have variance and standard deviation. So in statistics, we deal with data in statistics, but data they are grouped into two. We have what you call, or you can say they are categorized into two. So we have what we call the ungrouped data and the group data. So the ungrouped data is just like the scattered data that has been scattered about. Okay, while the group data has just been grouped in an orderly fashion because the data is so much that it will be difficult for you to pick your ends on it, just put your hands on the data. So to make it much more, you know, much more useful, it has to be grouped. So we'll be using group data that has been put into class intervals. Okay, that's what we're going to be using in this video. So we're using groups data, but the topic is still variance and standard deviation. Okay, still variance and standard deviation. So when I say on group data, just to clarify that on group data is data that has something like, you know, if I give you maybe the data of the sizes of the shoe of some people in a school, okay? Maybe someone is 23, someone is with 23, size 23. And then you move on to maybe another person with size 34 and 35, sorry. And then another person might have size 23. Another person might have size 67. Another person might have size, let's say 45. And so on and so forth, as many as possible. But this kind of data is ungrouped, so it's a scattered data. So to make a data to be much more effective, to be much more interactive, it has to be grouped properly. So that's what you call group data. So that's what we're going to be dealing with. And when we say group data, we mean something like, instead of saying 23, how many are they? 24, how many are they? 25. We just group them into one. Like, let's say 23 people that are with size 23 to size 34. Okay? That dash that I put there is not minus, it's 23 to 34. So people that are with size 23 to 24, 34, they'll be grouped aside. So we'll count everybody that has the shoe size of 23 to 34. And then we group them together. And then we can move on maybe from, because we stop at size 34, so we can go on people with size 35 to, let's say size, this is 7, 11. So let's say size 46. All right, and so on and so forth. So what you just did is that you group them. It's not necessarily that you will have people with size 35. It is not necessary. Okay, it's not necessarily that size 35. It's just everybody that falls within the sizes of 35 to 46 shoe sizes, I meant. So this is a way to group data, a much more, nice, better way to group data. So data can be grouped like this. And what you call this, we call them a name. We call all this type of grouping, we call them class intervals. Okay, class intervals. So there are classes of sizes of shoes of some student in a school, in wherever the data is from. So we call them class intervals. So if we group this to class intervals, and if we want to use the data, we want to use it to find the variance and standard deviation, we have to convert the class intervals into what you call class marks. Class marks. Okay, class marks. So when you convert it, you'll be able to interact with it properly and be able to find the variance and standard deviation. So let me start because of our time. So I'm going to take all of this off. I'm going to start. So, all right, let me start with variance. Now, variance has a mathematical expression. The mathematical expression for variance is this. We call this summation. Let me pinpoint that properly. We call that, this means summation f multiplied by, summation of, let me go back a little bit so you get it. Summation of the value of all these guys here, including the f. Okay, summation of f multiplied by x minus s bar. S bar means mean. S minus s bar square. So you have to first of all work with s minus s bar square before you multiply it by the frequency, and then everything divided by this n. N means total number of people that we are dealing with in the data, or you call it total number of frequency. Frequency means number of occurrence. Like if I call people from 23 to size 34, what are the total number of occurrence? Like how many people have sizes within that range, within that class interval? So, but if I'm now taking many groups, 23 to 34, 36 to 46, and so on and so forth. So everybody all together, the total number of people I'm dealing with all together, as the value of n. Okay. So standard deviation. Standard deviation is just simply defined as the square root of the variance. As you can see, the variance is inside the square root. Okay, but instead, the variance is inside the square root. So instead of just this value standing alone, we have a square root outside of it. That's just the difference. Once you have the value of your variance, then your standard deviation is going to be the square root of that variance. So for instance, let's say if my value is let's say my variance is just 16, then my standard deviation, once I have my variance, then my standard deviation is just going to be 4. That's the square root of the variance. That's what it's all about. All right. So moving on to the meaning of each of the parameters. Like I said, frequency is number of occurrence. X is the individual data. Okay. While X bar, we call that X bar. This thing is called X bar. This guy here is X bar, but the true meaning of X bar is mean. Okay. Everybody's familiar with how to find mean, like the mean median mode aspect. We know how to find mean. Mean is by adding everything together and dividing it by the total number of occurrence. Okay. So, and this n right here, like I said, is total number of frequencies. And then this symbol is called sigma. Sigma means summation. And there's this two lines that look like 11. It's called absolute value. Absolute value, meaning if you call something an absolute value, for instance, if maybe you did a little bit of calculation and then let's say you got minus 6. Now if I ask you to give me the absolute value of minus 6, when I say the absolute value of minus 6, I mean the exact value itself, neglecting sign, if it's positive or negative. We are just taking the absolute value. Absolute value. No sign, nothing. Just the value itself. So the absolute value of 6 we just give minus 6 rather, we just give you 6. So the absolute value of minus 7 is just 7. The absolute value of, let's say, plus 34 is just still 34, which is the same thing as plus 34. So if you have a negative value and you need the absolute, then the absolute has to be the value itself, forgetting about this sign, either negative or positive. So that's just what it's all about. Okay, so let me get rid of this. Alright, so let us move on. So let's move on. Now, I'm going to jump straight to the questions because this video I plan to make it very short. Okay, I don't want to make it too long. So the first question is this. This is the question. These are the shoe sizes of men for NYSC. 100 men for an NYSC. I mean, not 100 men. This is a little bit of mistake right there. It shouldn't be 100 men. This here shouldn't be 100 men. This should be 71. 71 men. I'm coming. Yes, this should be 79 men, not 100 men. So I've corrected that, please. Sorry about that. So it will be 79 men. So the table below is that of shoe sizes of 79 men for NYSC. We don't know where the NYSC is. It's just the data that's been extracted. So the shoe sizes are grouped into class intervals. They're grouped together. Okay, we have this here, which is 50 to 54, 55 to 59, 60 to 64, 65 to 69. So those are the group, and these are their individual frequencies: 7, 15, 44, and 13. All right. So, and then a question asks us to go ahead and find the variance and standard deviation. So we're going to be using the expression for variance and standard deviation. I'm going to start with variance first. Okay. So with variance, so as you can recall, variance is this. This is the expression for variance. So if that's the expression for variance, we are going to be using this expression for variance. We are going to be using that to plot a table for our values. Okay, we are going to plot a table. So, or you can say we're going to construct a table, whichever the English applies. So I'm going to use that to construct a table. So the table goes thus. The first thing, if you're working on variance and standard deviation, the first table you're going to work with is this, which is your class interval. If it is a grouped data, you start with the class intervals as seen from the question itself. But if it is, let's say it's, if not a group data, maybe instead of 50 to 54, I only wrote 50. So I'm not going to be needing class intervals at all. The only thing I'm going to be having is just class mark. That's all. That will just be my X. So in that case, since it is class intervals, so this is how my table is going to be. My table is going to start with class intervals, and then to follow with class mark, to follow with frequency, and then fx. Fx, not 4x. Fx, that means f times x, the frequency multiplied by the class interval, and the class mark rather. So I'm also going to be doing x minus s bar. So s bar is mean. So that means in this data, in this analysis, we're going to have to find the mean. And then once we have the mean, whatever we have here, whatever we get in this place, we're going to then square it. So once we're done squaring it, we're going to then, whatever we get from the square in this column, then we're going to take the frequency and use it to multiply it so that we can have this column. Okay, that's what we're going to be doing. So I'm going to be starting in a moment right now. So let me get rid of what I have there. So let me begin. I'm going to start with class intervals. So I'll begin with 50 to 54. So you can see there, that's 50 to 54. Then we'll move on to 55 to 59. That's how you list them one after the other. Then 60 to 64. Then 65 to 69. Now, how do you get a class mark? The class mark is gotten by taking the lower class intervals. 50 to 54. The one that is 50 is the lower class interval, and the one that is higher, that's beside the 50, is the upper class interval. So I'm just going to add 50 plus 54. Then whatever I get, I'm going to divide it. So I'm going to divide this by 2. So if I divide this by 2, whatever value I get here is going to be my class mark. That's what I'm going to be doing for this place. Okay? So let me get rid of what I have there. So now I'll start with the class marks. So the class mark, the first one, which is for the 50 to 54. So if I add 50 plus 54 and then I divide it by 2, please, it is divided by 2 to get the class mark from your class interval. You use the 2 class intervals, 50 to 54, that's what we have here. So you add the both of them together and you divide it by 2. So if you divide it by 2, you get 52. So 50 to 54, divide 50 plus 50, add 50 plus 54 divided by 2, you get 52. So the next one is 50 to 55. If you add the 2 of them together and you divide it by 2, you get 57. And then 60 plus 64 divided by 2, you get 62. And then 65 plus 69 divided by 2, you get 67. Now let's go ahead and include the corresponding frequencies. Yeah. So the first one, which is 50 to 54, from the data originally. It's not that I just come up with the frequency. This is the data originally here. These are data originally right here. This data. So under the data, you can see the frequencies, each of them. Those are the frequencies. So that's what I'm going to add here. That's what I'm going to put here. So I'm going to put each and every one of them there. So for their corresponding frequencies, the first one is 7, the second one is 15, the third one is 44, the next one is 13. So for fx means frequency multiplied by the class mark, or you can just go ahead and say xf, whichever works, because the both of them are multiplied by each other. So frequency multiplied by class mark, or class mark multiplied by frequency. So that means 52 multiplied by 57. This is what I'm talking about. This part right here. This place. Let me make that smaller, so I don't cover the whole place. So this is the part I'm talking about. 52 multiplied by 7. That's the part I'm referring to. So if I multiply 52 by 57, I'll be having, so I'm going to be getting, I'll be having 364. If I multiply 57 multiplied by 15, I'm going to be getting 855. Then 62 multiplied by 44, I'm going to be having 2,728. Then the next one is 871, that's 67 times 13. So after I'm done with that, I need to move on to x minus x bar. So I'm talking about this part here. I need to move to this. So in order to do this, I need to find the x bar, which is the mean. And generally, mean is calculated. Mean x bar is calculated by doing summation fx, okay, summation fx divided by summation f. It means I'm going to do the addition of all my fx and the addition of all my f, divide them to get the mean, so I can go ahead and work this column. Okay, so that's what I'm going to do. Okay, so let me go ahead and do that. Now, that means I need to find the mean. Then you have to write the mean as part of your workings. So I'm going to write the mean. Mean is that. Then how do I get my summation fs? I can get my summation fs from the table. So from the table, where's the fx? As you can see, the fs colon. So, the f colon first, which is 79. So if you add all the f's together, all the frequencies, that's 7 plus 15 plus 44 plus 13, that's 79. So for the fs colon, that's 364 plus 855 plus 2728 and then plus 871. So you get 4808. So then you divide them together. So if you divide them, you're going to be resulting into 60.99 millimeter. Why am I adding millimeters? Now the unit is very, very important. Millimeters here, this is what I mean. This mm is very important. Reason is this shoe is in millimeters. So if the shoe is in millimeters, then the unit of your mean must be the same unit as those sizes. If it's variance you're doing too, you have to add the unit. If it's standard deviation, you have to add the unit at the end of your value. So that's why I have my unit right there. So that's my mean. So I'm going to be going ahead and be doing x minus x bar, meaning I'll be taking each of the x's. I'll be doing 52. This is what I'm doing, 52. I'll be removing 52. 52 minus 60 point, okay, 99, because my mean is 60.99. So I'm going to be having a result of negative, but because of this absolute symbol, I'll be neglecting the negative, because if you do 52 minus 60.99, you're going to be having negative. So I'll be neglecting the negative. That's the meaning of the absolute. We need the absolute value. So I'm going to be going ahead in a moment now. Okay. So now, as you can see, the true value is 8.99, but the true value is minus 8.99, but we need the absolute value, which is 8.99. I'm going to need you guys to be working with me as I'm doing this, because I want to make this video to be very, very fast. I don't want to waste a lot of time on it. So you can pick up your calculator and do the calculation and see for yourself that 50 minus 60.99 is negative 8.99. That's minus 8.99. So I need the absolute value. I'm going to neglect the negative. So the next one is 3.9. That's 57 minus 60.99. So it will result into negative 3.99. I'm going to neglect the negative. Now 62 minus, the next one is 62 minus 60.99. That one is not giving me any negative. So I'll just report the value just like that. So that's 1.01. Then the next one is 67 minus 60.99. That's 6.01. Okay. Please, I need you to follow me. This is what I'm doing. I'm doing this 67 minus 60.99. That's what I'm doing. That's how I got 6.01. Okay, these are my individual x's. So I'm removing 60.99 from each of them to get this column. Okay. So the next column is this. So whatever I have in this column, I'm going to square it. That's what it means. So I'm going to square that. So if I square 8.99, I'm going to be having 80.82. Okay. Then if I square 3.99, I'm going to have 15.92. If I square 1.01, my result is 1.02. If I square 6.01, the result is 36.12. But I don't need the sum. I do not need the sum of this part. I don't need the sum of this column. Nope, this is the column I need, this one. Because variance itself is summation f into bracket s minus s bar square, and that is what we have here. we need to find each of the values in this column, then we add them together. That's the meaning. So that's what I'm going to do in a moment right now. So now if I square 80.82, my result is going to be 565.74. Okay, and if I square 15.92, the result is going to be 238.8. Then if I square 1.02, I'm going to have 14. Okay, this is wrong. Okay, let me go back a little bit. Sorry. So yeah, I'm going to go back a little bit because I made a little bit of error right there. So what I mean here is that what we are doing here, please, you don't have to make mistakes. Please be careful of errors. What we're doing here is f multiplied by s minus s bar, meaning we are taking the frequency, we're multiplying it by this. We're multiplying the frequency by this. So if we're multiplying the frequency by this, we're going to be getting the value for each of this column. That's what it means. Okay. So I'm going to be doing that right now. So if you do that, that's 7 multiplied by 80.82. You're going to have 565.74. 15 multiplied by 15.92. You're going to be having 238.8. And then 44 multiplied by 1.02. The result is 44.88. And 13 multiplied by 36.12. The result is 469.54. So we are going to go ahead and sum that up. So when we sum that, that is 1318.98. So that is our summation f multiplied by s minus s bar square. So we're going to go ahead and go to that variance up there, and then we're going to input that. Remember I told you that n is the same thing as, okay, I haven't talked about that. N is the same thing as summation f. When you say total number of frequency, you're still saying all the summation of all the frequencies, so which is still 79. So that means we're dividing the summation of f into bracket f multiplied by s minus s bar square. Okay, some people use bracket, but it's actually absolute value, not really bracket. So when you do that, you're going to have a result of 16.7 millimeters. Now we've found the variance. So what about the standard deviation? Standard deviation can also be represented with SD, okay, as a short form of standard deviation. Now, standard deviation is the square root of your variance. Whatever you get for your variance, once you have a variance is the hardest. Once you have a variance, standard deviation is easy. So once you have your variance, then you can square root the value of your variance to get your standard deviation, and then when you square root that 16.7 millimeters, then you're going to have a result of 4.09 millimeters. So guys, that is what it's all about. Okay, variance and standard deviation is quite simple. You might get much more longer data than this, because this is just 4 data, because I don't want to waste so much time on this video. So just four grouped data. Okay, you can have much more longer ones, which is what I'm going to review to you in the next question, and you'll be solving that yourself. So once you have the question, once I show you the question, you can pause the video. Once you pause the video, solve it. Okay, once you solve it, play the video right back, and then you get the solution. If you get the answer, you know. If you don't get the answer, you see it. So that's what I'm going to do in the next video. So the next video, for question 2, this is the data. Age in years, and 40 to 44, 45 to 49. So you have to find the variance and standard deviation. So you can pause this video and then come back to see whether you are right or wrong. Solve it by yourself and then come back to see whether you're right or wrong. So the answer in a moment. Alright, so I believe you've paused the video, you've solved the question, Now this is the answer. The variance is 40.84 and the standard deviation is 6.39. But remember, it's supposed to be in years, okay? Because from the data is dealing with age of some people. So it's supposed to be 40.84 years. And then standard deviation should be 6.39 years. Right. So now another question. Question 3. So question 3 is in kilogram. We have weights of some people, which is 20 to 29, 30 to 39, and so on and so forth, and their corresponding frequencies. So you are asked to find the variance in standard deviation. So you can go ahead, pause the video, and then once it's done, you can come back and check the answer. So you've done that, good. Now these are the answers. We have the variance to be 206.84 kilogram, and standard deviation to be 14.38 kilogram. Right? So that's what it's all about. So I don't want to make this video to be longer. If I want to go really deeper, I'm going to have to show you the table. Okay, show you the table, solve the variance and standard deviation and all of that. So, but from the first question, I've been able to describe how to do it. Okay, you can use that example to deal with these ones. So that's everything. Thank you for watching. Have a nice day.